Hello everyone, in this video we are going to learn about surd and rationalizing denominators. What is surd? If n is an integer that is not a square number, then any multiple of square root of n is called a surd. What is a square number? Square numbers such as 4, 9, 16, and so on. Because 4 equals to 2 squared, 9 equal to 3 squared, and 16 equal to 4 squared. Thus, we call this 4, 9, 16 a square number. And let me give you some example of the surd, such as square root of 2, square root of 11, and 5 times square root of 2. Also, surd is an example of the irrational numbers. How do we do the calculations between the surd? We have two rules. The first one is square root of AB equal to square root of A times square root of B. And the second one is the square root of A over B equal to square root of A over square root of B. Let's do some exercise. Simplify the first question, the square root of 16. How do we, 60, square root of 60, how do we simplify it? We find the factors of the 60 is 4 times 15. So we can write equals to the square root of 4 times 15, and then equals to square root of 4 times square root of 15 equals to 2 times square root of 15. Thus, we get the answer, right? Now, let us see the second one. How about square root of 20 over 2? We get that the square root of 4 times 5 in the denominator, and denominator we keep the 2. Then we can write as the square root of 4 times square root of 5 in the denominator and still 2 in the denominator. This we get that 2 times square root of 5 over 2, and simplify it, we cancel the 2. What we left the square root of 5. That is answer. Let's do the third one. Square root of 12 plus 3 square root of 48 plus square root of 75. Well, it's quite long, but we can do it. So we can write that the square root of 3 times 4 for the square root of 12, because 12 equal to 3 times 4, we find the two factors. And similarly, we get 3 times square root of 3 times 16 plus square root of 3 times 25. And then we get that square root of 3 times square root of 4 plus 3 times square root of 3 times square root of 16 plus square root of 3 times square root of 25. Simplify that, we get that 2 square root of 3 plus 4 times 3 square root of 3 plus 5 square root of 3. This we get 3 times 4, we get that 12. Thus we have 19 square root of 3. That is answer. Now let's move on to the harder one, like expand and simplify. So for the first question, we get that square root of 2 times 3 minus square root of 3. So we expand that, we get 3 times square root of 2, and another one is square root of 2 times square root of 3 minus that. And thus we get 3 square root of 2 minus square root of 2 times 3 equals to 3 square root of 2 minus square root of 6. That is answer. For the second question, we get that 4 plus square root of 5 times 3 minus square root of 5. How do we do that? So we expand it firstly. So it's 4 times 3 minus 4 times square root of 5 plus 3 square root of 5, and then minus square root of 5 times square root of 5. What do we get? 12 minus 4 square root of 5 plus 3 square root of 5 minus 5, right? Because square root of 5 times square root of 5, we get square root of 25, thus equal to 5. Then equal to 12 minus square root of 5 minus 5 equal to 7 minus square root of 5. That is answer. Let's see an exam question. So also expand and simplify. 2 plus square root of 3 times 7 minus square root of 3 and give your answer. In the form a plus b square root of 3, where a and b are integers. So how do we do that? So 2 plus square root of 3 times 7 minus square root of 3 equal to 2 times 7 minus 2 square root of 3 plus 7 square root of 3 minus square root of 3 times square root of 3 equal to 14 plus 5 square root of 3 and minus square root of 9, which is equal to 3. Thus we get 11 plus 5 square root of 3. So a equal to 11 and b equal to 5. Now let's move on the another one, and let's move to another stage. Second stage, we talk about the rationalizing denominators. So what is rationalizing denominators? When we have a third in the denominator, we sometimes to rearrange it so that the denominator is a rational number. Then what we do is called the rationalizing denominator. There are three rules to rationalizing denominators. So the first one was 1 over square root of a. What should we do? We times square root of a both on the numerator and denominator. And what we get is the square root of a over a. The second one, we have 1 over a plus square root of b. So how do we do that? We times a minus square root of b on the both top and bottom. We get that 1 times square root of 1 times a minus square root of b in the numerator, and a plus square root of b times a minus square root of b, which equal to a minus square root of b over a squared minus b. Let's quickly recap what happened over here. In this process, we use the differences of squares, which is x squared minus y squared equal to x plus y times x minus y. We use this one in this process. Now the third rule is 1 over a minus square root of b. It's similar to the second one, so we times a plus square root of b, also use the difference of the square. So a minus square root of b times a plus square root of b equal to a plus square root of b over a squared minus b. That are the three rules we use to rationalize denominator. Let's do some exercise. So rationalize the denominator. The first question, we have 1 over square root of 3. How do we do that? We times square root of 3 to the both numerator and denominator. Use the first rule. We have square root of 3 over 3. For the second question, we have 1 over 3 plus square root of 2. So use the second rule. We do that 3 the second one. 3 minus square root of 2 over 3 plus square root of 2 times 3 minus square root of 2. We get 3 minus square root of 2 over 9 minus 2. Right? Because that is 3 squared. That is square root of 2, and square that, we get that. So equal to 3 minus square root of 2 over 7. Let us do the third one. So 1 over 1 minus square root of 3, and square that. How do we do that? So firstly, we need to expand the bracket. We get that 1 over 1 minus 2 square root of 3 plus 3 equals to 1 over 4 minus 2 square root of 3. And then we can use our rules to rationalize it. We get that 4 plus 2 square root of 3 over 4 minus 2 square root of 3 times 4 plus 2 square root of 3. Then we have 4 plus 2 square root of 3 at the denominator, and in the denominator we get 16 minus 12. Well, 16 equals to 4 squared, and 2 square root of 3, square that, we have the 12. Then we have 4 plus 2 square root of 3 over 4, and we can cancel the 2 at the both top and bottom, and we get that 2 plus square root of 3 over 2, right? We simplify it. Let's see an exam question. Right. Square root of 18 plus 10 over square root of 2 in the form p plus q square root of 2, where p, q are integers. So how do we do that? Square root of 18 plus 10 over square root of 2, so we need to rationalize the square root of 2 in the denominator over here. We need to rationalize it. So we need to times the square root of 2 on the both numerator and denominator. So we have square root of 18 plus 10 times square root of 2, and the square root of 2 times square root of 2. What we have, we need to expand the bracket, so it's square root of 18 times 2. Times the square root of 2, we have square root of 18 times 2, and the plus 10 square root of 2. And in the denominator, we have 2. And calculate, we have square root of 36 plus 10 square root of 2 over 2. Square root 36 is a square number. We can have 6 plus 10 square root of 2 over 2, and simplify it. We can cancel 2. So 6 divided by 2 is 3, and 10 divided by 2 is 5. What we left is 3 plus 5 square root of 2. Thus, P equal to 3 and Q equal to 5. That's what we have learned in this lesson. You can pause the video to see the conclusion and make notes. Thank you for your watching.